Good morning, students. Welcome to Narayana Online Classes. Today we are going to discuss about the terms related to the spherical lens. So we have here 8 terms regarding the spherical lenses. So let us see one after the one in this assignment. So this is the assignment of 18th June and 10th Cbse. So let us see one after the one and let me explain each and every term regarding to the spherical lenses. So let us go with the first one. What is that? Here it is optical center. So let us see what is this optical center. So whenever we consider a convex lens, the center of this lens or the geometric center of this lens is called as optical center O. So this stands for the optical center. So through this optical center, the reference line, the principal axis will pass through this optical center. So the point of intersection of this principal axis as well as the center or the geometrical center of this lens is known as optical center. So for example, whenever we consider any ray that is passing through this optical center, the ray passes without any deviation. So any ray that is passing through this optical center passes undeviated. So this is the case of convex lens. For example, let us consider the concave lens. So in the concave lens case also, optical center is defined as the center of the lens through which the principal axis will pass through. So principal axis passing through a point known as optical center O. So any ray that is passing through this optical center will go undeviated. So the angle of deviation or the deviation in this case will be 0. So any ray that is passing through the optic center passes undeviated. So this is about the optical center in the case of concave lens as well as convex lens. So let us see about the centers of curvature. The next one is centers of curvature. So in the case of centers of curvature, they are defined as the center of the surface of the sphere through which the lens is a part. For example, whenever we are considering a sphere, so imagine it is the big optic sphere. So from this optic sphere, we are selecting some part of the lens. So this is the part of the lens, we are removing it. So this is the part of the lens, we are removing it. So you just imagine this is the part of the lens we just removed. The center of this complete optic sphere from which the lens was prepared is called as the center of curvature C. So the center of curvature in the case of concave lens as well as convex lens, let us see one after the one. Let us consider this is the principal axis. Let me draw a convex lens. Is a biconvex lens. So there will be the two curved surfaces. With respect to this first curved surface, so we can take the first curved surface. So let me show you with the blue color. So this is the first curved surface of the lens. So with respect to this first curved surface, the center of curvature C1 will lie on the right side. So whereas if we consider the second surface, so this is the second curved surface of the biconvex lens. So with respect to the second curved surface, the center of curvature C2 will lie on the left side. So we can define the center of curvature or the centers of curvature of the lenses as it is the center of the sphere from which the lens was separated or the lens was prepared. So for in the case of biconvex lens, we will have two centers of curvature. So in the same manner, if we consider a biconcave lens, there will be the two curved surfaces and let us consider this is the principal axis. And let us place the optic center and here also the optic center. So with respect to this first curved surface, the center of curvature will be on the left, and with respect to the second curved surface, the center of curvature will be here. So this is all about the centers of curvature. So let me define the next one. The next term is principal axis. So if we consider a convex lens, this is the optic center, and there will be the centers of curvature C2, and on the other side there will be C1. So principal axis or the central axis is a line that passes through the centers of curvature and the optic center. So the line that is passing through the centers of curvature and the optic center is defined as the principal axis. So this reference line is known as principal axis. So we can define the principal axis as the straight line passing through centers of curvature and the optic center or optical center. So the straight line passing through the centers of curvature and the optical center is known as principal axis, or there is another name for this principal axis. It is also called as central axis. So this is all about the principal axis. So let us see about the next one, that is aperture. So let us see what is this aperture. For example, we consider a convex lens or a concave lens. Whatever the lens it is, either it is a convex lens or a concave lens, the diameter of the boundary of this lens, is known as aperture. So in this case also, the diameter of the boundary, for example, if we see the lens from this view, it appears to be circular. The diameter of this lens we are calling as aperture. So the lens with more aperture allows more light to pass through it, so the intensity of light passing through that lens will be more. The aperture increases the amount of light that is passing through the lens. So aperture also determines the size of the lens. So in this case also we can call it is aperture. So we can define the aperture as aperture is the diameter of the boundary of the lens. So this is the definition for the aperture. So let us see about the principal focus. So let us see about the next one is the principal focus. So in the case of convex lens, if we consider this is the principal axis and it is the optical center, let us consider a parallel beam of light or a paraxial ray. After refraction, the paraxial ray, after refraction, it intersects the principal axis at a point, and this point is known as focus. So focus or the principal focus is defined as the point on principal axis, the point on the principal axis through which the refracted ray converges or appears to diverge So principal focus is defined as a point on the principal axis through which the refracted ray converges or appears to diverge. So we can see in the case of concave lens. So let us consider this is the concave lens, and let us draw this is the principal axis, and it is the optical center. So if we consider a parallel beam of light, so it diverges out in the case of a concave lens. So we can find it appears to diverge from a point known as focus. So we can say here the refracted ray converges at focus in the case of convex lens, and they appear to diverge from focus in the case of concave lens. So just we can see here this is concave lens. So in concave lens they appear to diverge out, whereas in the case of convex lens they converge at a particular point on principal axis known as focus, or it is also called as principal focus. So let us see what is the next one, focal length. So focal length is the distance from principal focus to the optical center. So in ray optics, every distance is calculated from the optic center or optical center. So let us consider this is the convex lens and it is the optical center, and here is the principal focus. So the distance from optical center to the principal focus is known as the focal length. So this is known as focal length. So we can say here focal length is defined as the distance between optical center and principal focus. Whereas in the case of concave lens, it is also the distance between the optical center to the principal focus. So this distance is also called as f, the focal length. So it is denoted by small f. Generally we use the small f. So this is about the focal length. In general, the focal length is always denoted by small f, and the units of this focal length will be meters or centimeters. So let us go with the next one, that is object distance. So the next one is object distance. So let us consider this is the lens and it is the optical center or the pole. If we place the object in front of this lens, so let us consider this is the object. So the distance between the pole or optical center to the object, this is called as object distance. So you can say the distance between pole and the object is the distance between the the pole and the object. In general, the object distance sign convention is always taken as negative, because in ray optics every distance is measured from pole or optic center. So we are measuring the distance or the object distance in the opposite direction to the direction of incident light. So we are going to take the sign convention for this object distance u is always negative. So object distance is denoted with a small letter u, so it is always negative. So this is all about the object distance. So the same object distance in the case of, if we just consider the concave lens, it is also the distance of the object from the pole or the optic center. The same definition occurs here. So let us go on with the last one, that is image distance. So let us consider the last definition, that is image distance. So image distance is the distance between pole and the image. So let us consider a convex lens, and let us say here is the object. So for tracing the image, it requires at least 2 rays. So minimum number of rays required to draw this ray diagram are 2 rays in order to track the image. So let us consider this is the first ray, which is paraxial. So after refraction, the ray will pass through the principal focus. Let us consider one more ray that is passing through the optic center or optical center or the pole, which passes undeviated. So both these rays will intersect at a point. At this point, the image formation takes place. So at this point, the image formation takes place. So here is the image and here is the object. So the distance between this pole or optic center and this image is known as image distance small v. So image distance is always denoted with the letter small v. So image distance is the distance between the pole or optic center to the image. So this is all about the image distance.